All right, guys, let's talk about lesson 2, which is calculating heat. So, calculating heats of reaction. So, Q is a symbol that we use for heat, and that is going to be equal to our delta H value. It's either going to be measured in joules or kilojoules. If Q is positive, the heat is endothermic, which means it goes into the system. If Q is negative, that means it's exothermic. Heat is going to be released from the system. And we talked about that when we looked at delta H in the last lesson. The heat of a reaction is based on three things: the mass of the substance, the temperature change it undergoes, and specific heat. Now, specific heat is the heat needed to raise the temperature of 1 gram of a substance 1 degree Celsius. So here are a list of different things, and you can see the specific heat for everything is different because it's the amount of heat needed to raise the object or raise the material, the temperature of that material, 1 gram of it, 1 degree Celsius. So for different things, that's going to require a different amount of heat because of the way the things are bonded, the way their structures are, so on and so forth. So the specific heat of water is located on table B in your reference packet. So we have the heat of fusion, which is 334 joules per kilogram. We have the heat of vaporization, which is 2,260 joules per kilogram. And then we have the specific heat of water when it's a liquid, which is 4.18 joules over kilograms times degrees Kelvin. So let's look at what our equation is. Q is equal to mc delta T, and that's going to be located on table T in your reference packet. Q is your heat, M is your mass of your substance, C is the specific heat of that substance, which if it's water, you look at table B on your reference packet. If it's not water, then it's going to have to be given to you in the problem. And delta T is going to be your final temperature minus your initial temperature. So this is going to be a very mathy section. So let's look at an example problem. Let's solve for the heat, which is Q. So the problem reads, how much heat is needed to raise the temperature of 500 grams of water by 15 degrees Celsius? So the first thing you want to do is you want to list what you were given in the problem. So in this problem, we were given our mass, which is 500, our C, because we're talking about water, so it's 4.18 joules divided by grams degrees C, and then change in temperature. It says that raise the temperature by 15 degrees, which means your change in temperature is going to be 15 degrees. So then step 2 is to determine the product. So what you're going to do is just multiply all three of these things together. So our equation is Q equals mc delta T. So we multiply 500 times 4.18 times 15, and everything cancels unit-wise, so we're good. So we get a Q equal to 31,500 joules. Since 15 only has two significant figures in it, we're going to round that to 32,000 joules. So that will be our correct answer for that problem. So let's look for an example when we're solving for C, for our specific heat. So here's an example. The temperature of 95.4 grams of copper increases from 25 to 48 degrees Celsius and absorbs 849 joules. Calculate copper's specific heat. So step 1, again, list what we're given. We know Q is 849 joules, and if you don't know that from reading the problem, look for the unit. Heat is always going to be in joules. The unit for the unit for Q is always going to be in joules. Then we have M, which is our mass, that's 95.4 grams. Then we don't know what our C is because that's what we're solving for, that's specific heat. And we know what our change in temperature is, which is going to be the 48 degrees minus the 25 degrees. Step 2 is we're going to determine the product. So we plug into our equation. And what we're going to have to do in this case is we're going to have to divide by 95.4 and 23 degrees Celsius. And when we do that, everything cancels, and we're left with a specific heat of 0.39 joules per gram degree Celsius. Alright, so let's look at a practice problem. How many joules of heat are absorbed when 50 grams of water are heated from 30.2 degrees Celsius to 58.6 degrees Celsius? I want you to pause the video, try this one on your own, and unpause when you're ready. Great, well, welcome back. Well, the first thing you should have done is listed what you were given in the problem. which you were given a mass of 50 grams. A C you can get from table B because we're talking about water, and our change in temperature, which would have been 50 minus 30.2, and we got 28.4. Then we are solving for Q because it says how many joules of heat are absorbed. So we're going to plug into our equation, and then we're going to multiply. When we multiply our answer out, we get 5,935.6 joules. Since in this problem, we need to have three significant figures, our answer needs to have three significant figures. So remember, let's review. 5 is significant, 9 is significant, 3 is significant. So that means that the 5 rounds the 3 up to a 4, and the 5 becomes a 0. So that's why our final answer is 5,940 joules. Let's look at another practice problem. How much energy, or excuse me, how much heat is needed to raise the temperature of 25 grams of water from 27 degrees to 47 degrees? Pause the video and unpause when you're ready. Great, well, welcome back. What you should have done first, as always, list what you're given. Again, we're talking about water, so you're going to use 4.18. Our change in temperature is going to be 47 minus 27, which gives us 20, and we're looking for Q, which is our heat again. So we're going to plug into our equation, and we're going to solve. Since in this case, we're multiplying, and we want to go by the number that has the least number of significant figures, which is 2, we need to round 2,090 up to 2,100 because that has two significant figures. All right, let's look at your check your understanding. How much heat is needed to raise the temperature of 100 grams of water to 50 degrees Celsius? And check your understanding too. The temperature of aluminum increases from 30 to 38 and absorb 900 joules. Calculate the mass of aluminum if you know the specific heat is 0.902 joules per grams times Kelvin. We're going to answer both these check your understandings in class tomorrow. Have a good night.